The observable universe is the part of the universe that we are able to see and research with telescopes, satellites, and other equipment. It encompasses everything from planets and stars that are nearby to the farthest galaxies that can be identified. This vast area of space contains light and energy that has been traveling for billions of years to reach us. But as immense as the observable universe is, it's worth noting that it has boundaries. And those boundaries aren't made of physical walls or barriers, but of time, distance, and the speed of light. Light, to our current knowledge, is the fastest signal in the universe. It moves at a fantastic velocity of approximately 299,792 kilometers per second, or roughly 186,000 miles per second. Nevertheless, even at this scorching pace, light takes time to cross the unimaginable distances in space. When we gaze upon the moon, we see it as it existed some 1.3 seconds back. When we gaze upon the sun, we see it as it was some 8 minutes back. And when we gaze at far-off galaxies, we see them as they existed billions of years ago. This delay of time makes for a cosmic time machine, enabling us to see back in history simply by looking upwards. The more distant an object is from the Earth, the older is the light we see coming from it. What this implies is that the boundaries of the observable universe are not merely distant in space, but far back in time. Some light we see today was produced just a few 100 million years after the Big Bang, and it's only now finishing up its great journey through space to arrive in our telescopes. But things and events that are so distant that their light hasn't arrived yet are still hidden from us. Those areas are beyond our observable universe, beyond the cosmic horizon. Based on the latest scientific calculations, the size of the observable universe is approximately 93 billion light-years across. That's a figure that will come as a shock, particularly when we take into account that the universe itself is approximately 13.8 billion years old. How could a thing be 93 billion light-years wide if the universe itself was only 13.8 billion years old? The answer to this is one of the most significant and brain-twisting fundamentals of cosmology, the expansion of the universe. Since the Big Bang, the universe has been expanding, not only matter and energy in it, but space itself. That is to say, galaxies are not merely moving apart across space, rather, space itself is expanding in all directions. When that occurs, objects become farther apart, even if the objects themselves aren't actually moving across space in the classical sense. Consequently, light which set out billions of years ago has had to travel farther and take longer than it would have had the universe been static. That is why the observable universe can seem significantly larger than the age of the universe in years. This cosmic stretching of space also impacts the light that reaches us. As space expands, it stretches the wavelength of light traveling through it, a process called redshift. Light from very distant galaxies is shifted into the infrared region of the electromagnetic spectrum, beyond ordinary telescopes' capability to see. This is where the James Webb Space Telescope enters. Designed by NASA with global partners such as the European Space Agency, ESA, and the Canadian Space Agency, CSA, the James Webb Space Telescope, or JWST, is the most capable space observatory to have ever been launched. In contrast to its predecessor, the Hubble Space Telescope, which was primarily geared towards observing visible and ultraviolet light, JWST is expressly designed to see infrared radiation. This enables it to look farther into the universe and to detect light from the first stars and galaxies, some of which had existed only a few 100 million years after the Big Bang. In a recent revelation that hit headlines around the scientific community, NASA announced that JWST had detected light from parts of the observable universe previously unseen. These areas are so far away that their light has been in transit for almost 13.8 billion years, basically since the beginning of the universe. By analyzing this old light, scientists get a view of what galaxies were like in their youth and learn about the development of the first cosmic structures to emerge in the universe. One of the most significant conclusions drawn from JWST's initial observations is that galaxies in the early universe created stars at far greater rates than ever assumed before. This indicates cosmic structures assembling quickly following the Big Bang, rewriting the history of galaxy evolution. It also reveals that ancient galaxies were denser, more turbulent, and more dynamic than the mature spiral galaxies of the present, like the Milky Way. As we venture further out into space and further back in time, we are necessarily faced with one of the most fundamental questions in science: are we alone in the universe? It has haunted mankind for centuries and is one of the most strong inspirations for contemporary astronomy and space exploration. If the observable universe has hundreds of billions of galaxies, and each of those galaxies has hundreds of billions of stars, some of which have planets, then the simple statistical likelihood implies that there could be life elsewhere. One of the most thrilling advancements in the quest for extraterrestrial life has been the sighting of exoplanets, planets circling other stars beyond our solar system. Since their first confirmed discovery in the 1990s, thousands of exoplanets have been detected by methods like the transit method, which observes a planet as it crosses in front of its star, causing its light to be slightly dimmed, and the radial velocity method, which detects small wobbles in a star's movement due to the gravitational tug of nearby planets. Among them are some that circle inside the so-called habitable zone, the band of distance from a star where conditions may be precisely suitable for liquid water to survive, a key ingredient for life as we know it. One of these exoplanets, which has drawn scientists' attention, is WASP 96b. Even though it's a gas giant and not a rocky terrestrial planet, it has given scientists a real understanding of planetary atmospheres. With the James Webb Space Telescope, scientists spotted water molecules in the atmosphere of WASP 96b. More unexpectedly, they observed evidence for clouds and haze, features they would not have predicted on this sort of planet. These findings indicate that our theories of planetary formation and atmospheric behavior could require an update. They also indicate that other, more Earth-like planets could potentially have atmospheres containing the precursors for life. But as we consider the likelihood of life elsewhere, we are compelled also to question more profoundly the nature of reality itself. Such a question is whether or not our universe is unique. This brings us to theoretical consideration of the multiverse. The hypothesis of the multiverse suggests that there could be numerous universes, perhaps infinitely many, beyond our own. Each could have its own physical laws, particles, and dimensions. Some would be similar to our own, while others would be dramatically different. The concept of the multiverse appears in a number of strands of theoretical physics, such as string theory and quantum mechanics. One interpretation of quantum theory, the many-worlds interpretation, suggests that every possible outcome of a quantum event actually occurs, but in separate, parallel universes. So, in one universe, you chose coffee this morning, in another, you chose tea. While the multiverse remains purely theoretical at this point, some physicists believe it could help explain otherwise puzzling observations, like why the fundamental constants of our universe are so perfectly tuned to support life. Yet the multiverse is still debatable. Without positive proof, some scientists see it as speculative or even unscientific. Others say that just because we cannot detect parallel universes at the moment doesn't mean they don't exist. After all, the observable universe was once inaccessible too. Another confusing and little understood phenomenon is dark flow. This is the phenomenon that some galaxy clusters are observed to be moving in a certain direction more quickly than can be accounted for by the known forces and matter distribution of the universe. Originally proposed in 2008, dark flow comes at the idea that something outside of what we can see could be pulling on us with gravity, some unseen structure or enormous lump of matter outside of what we can observe. Some research has upheld the dark flow theory, but others have been unable to verify it, and it is still a widely debated concept. If dark flow is an actual thing, it might be one of the strongest hints that something gigantic lies beyond the boundaries of our cosmic sight, possibly even another universe. But for now, it is uncertain. More information, improved equipment, and more penetrating surveys will be required to tell if dark flow is an actual phenomenon or a product of measurement artifacts. Whether it's galaxies on the fringes of the observable universe, exoplanets potentially hosting life, parallel universes, or strange motions such as dark flow, there is one fact that doesn't change. The universe is so much more complicated, lovely, and mysterious than we ever conceived. Each new finding contributes to what we know but also makes us more mysterious. Each time we solve a question, we reveal 3 more. In a sense, we are only just starting to explore the cosmos. Devices such as the James Webb Space Telescope are revealing new windows on the past and enabling us to construct a history of the universe, from the origin of the Big Bang to the creation of planets, and perhaps even to the beginnings of life elsewhere in the universe. As science proceeds, so too does our capacity to frame better questions, and one day, conceivably, discover some simply breathtaking answers. So, what do you guys think about all this? Are we alone in the universe? Is there something more out there than what we can perceive? Could dark flow and the multiverse be pointing to realities beyond our imagination? Let us know in the comments. And don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next trip to the depths of the universe's mysteries.